Hey everybody, welcome back to our 6-week webinar, The Magic of Pretest and Post-Test and Longitudinal Data Analysis. William Bannon of Stats Whisperer here with you again. Alright, so here we are, week 5 already. So our agenda tells us today we will be looking at special considerations in pretest, post-test, and longitudinal data analysis. So, longitudinal data analysis examines how outcomes change over time at specific points, right? However, what if you wanted to examine a factor such as relapse of smoking, drinking, illness, right? Over a period of time when you didn't know when it would occur. Now, in this case, the traditional methods we've been looking at, such as regression and different forms of analysis of variance ANOVA, are ill-suited for such an analysis. Right, so the relapse is what we refer to as an occurrence, right? Whether something or not happens. So the test we are discussing here is when you have to test whether or when a relapse occurs. So if that's the question posed in the research question, what sort of analysis can we do? So this brings us to the topic of today's discussion, the special consideration of whether and when, the use of survival analysis. So this is a specific statistical technique, right, that's very valuable to know. And we will look at two of the most popular forms of survival analysis today. So survival analysis is used when a researcher must describe whether an event occurs. Right? So does somebody over their life period get married? Yes or no? Or when an event occurs, such as mortality. Right? So that's not a question of if it occurs, it's when it occurs. So when we're looking at these sort of questions over a period of time, we can use survival analysis. It's important to realize we can examine an event that occurs just once, right? So over a period of 4 years, when does high school graduation occur, right? Once, or multiple times over a period. So over 20 years, how many times does a study participant leave a job? Now, there are 3 features common to every survival analysis study. There's a well-defined event. Well-defined meaning you know if it happens or not, right? So such as high school graduation, you know whether it happens or not. Right? So you're walking down with a gown and someone hands you a high school diploma. That's pretty clear. Right? So, and then a clearly defined beginning of time. So if we want to examine someone after high school graduation, we know when that occurs, right? Immediately after the ceremony. Right? So it's a clearly defined beginning of time, and then a metric. So if we're following somebody, is the time metric going to be minutes, hours, months, right? But it's a defined metric that we can quantify. So the research question for a survival analysis may reflect all these features. For example, we might say in a research question, after a smoking intervention, in how many days does the average person relapse into smoking? So there we have the clearly defined beginning after the intervention, right? So right after the intervention, and then our metric of time for following the person in how many days, number of days, and then the event, the average person relapse into smoking. So relapse into smoking is the event. Now, the time should be measured in as precise units as needed. So perhaps if we're following someone to over relapse, it might be more valuable to look at days or weeks rather than minutes, unless there's some reason that we think the relapse might be very quick. Right, so the thick units are referred to as discrete units. Right, so that's more of a categorical type of unit. Now the thin units, such as minutes, and days and weeks, following them over time, are continuous. Now in the research question, consider the term we had there. We had an assumption built in. It said does the average person relapse into smoking? Now, you may have thought that not everybody is going to relapse, right? So what do you do when people don't relapse into smoking? Those become known as censored cases. So censored cases are cases where the study participant does not experience the event, such as relapse, over the study period. So they may be censored because they drop out of the study, attrition, or they might be censored because at the end of the study period they still didn't experience the event. But censored cases are an important term for survival analysis. Now, there are a few types of censoring. We need to be familiar with the terms before we move into actually doing the analysis, which will wrap everything up together. But just preliminarily, let's go over the types of censoring. So there's non-informative censoring, and so that even though it's not informative, it's actually the preferred type of censoring. It's where the censoring is under the investigator's control. This is what we just mentioned. There's maybe dropout in the study due to attrition, due to something natural, such as somebody relocates. Perhaps the study participant just doesn't want to be in the study anymore, or at the end of the study period, they have not experienced the event, right? So then that's non-informative censoring. The informative censoring occurs when the dropout of the study occurs related to the event. So if somebody relapses into smoking and then they don't want to tell the investigator for whatever reason and they drop out of the study, well, then the dropout is related to the event, but we don't know that. And because we don't know that, we don't classify it that way, and introduces bias in the findings. Right? So there's someone experiencing the negative event or the positive event even, and we just don't know about it because they dropped out because they experienced it. So we don't know it was experienced. Now, most survival analysis assumes that censoring is non-informative. Now, the other types of censoring are right and left. Okay, so the right censoring, that's preferred. That's where the event time is unknown because the event occurrence is not observed. Right, so right censored. Right, they're censored because they didn't have the event over the observed study period. Left censoring, right, the second one, is the event time is unknown because the beginning of the test time was not observed effectively. Right, so this is where if we're examining how somebody behaves after they develop a certain disease, but we start monitoring them after they develop the disease, right? So again, most survival analysis experiences right censoring. That's the most common. Now, when we get to the data, you're going to see that the cases that are censored actually have time to event values, right? So even though they're censored and they didn't experience the event, they still have, per se, if you're measuring the time in weeks, a number of weeks entered, even though they didn't experience the event, which is kind of strange, but that time represents when they dropped out of the study or when observation stopped. But it's entered at the same place the other cases experienced the event. So we'll go over that in the data. But that's important to know because it can be perplexing. All right. So the first statistical analysis, the first survival analysis we will look at is the Kaplan-Meier, also called the product limit method. Right, so this is a non-parametric method that estimates the probability of an event, right? So when something occurred over a survival curve, right, that's dichotomous, past given time points, 1 week, 2 weeks, 3 weeks. The survival distributions can compare 2 or more groups. So how do these 2 or more groups do in experiencing the event over a certain amount of time? And was it significantly different? Which brings us to our sample study. So suppose all 100 people, right? So whenever we encounter a new statistical test, we want to illustrate it through a sample study. That way this can serve as a template for your actually implementing the same type of analysis. So in the sample study, our sample study that we've been using thus far, let's suppose that all 100 people in our intervention smoke cigarettes and they want to quit. So we want to determine the relative effectiveness of the intervention on 3 groups, because we're going to introduce a third group here, right, on long-term smoking. First, we're going to look at our experimental group, right? So they're all quitting smoking right after the happiness intervention and also this hypnotherapy group. So we have 3 groups all quitting smoking at the same time, and we want to see who relapses, like the percentage of people that relapse within each group over a given period of time. So we have our experimental group, which is 50 people, our control group, which is 50 people, and our new third group, which is our hypnotherapy group, which is also 50 people. So we'll be monitoring 150 people and their rate of relapse into smoking. So we want to determine if and when smokers that quit after the intervention smoke again. So yes, no, right? So we could call it just lighting up one cigarette, because if you quit smoking and you light up one cigarette, it's probably not just going to be that one. Not right away, but eventually. As I said, at Casablanca, and soon, and maybe the rest of your life. Okay, so participants were observed for 2 years, 104 weeks after the interventions concluded. So a successful result would be where smokers either don't start smoking again, or there's a longer length of time in between when they quit and they start again. So for example, if participants in the experimental intervention group start smoking toward the end of the 2nd year, and participants in the control intervention group start smoking at the middle of the 1st year, then the experimental intervention group would be considered more effective, right? Because that intervention group started smoking at a later period, right? It didn't work forever, but it worked longer than the control group. So what do we want to do in this Kaplan-Meier, right? We have our 2 goals. First, we wanted to determine if there's a statistically significant difference in the survival curves, the survival distribution for the 3 interventions, right? So are the 3 curves significantly different, right? And then second, if the 3 curves are significantly different, we want to know which intervention group is significantly different from the others and which has the most positive outcomes. Sometimes we call this pairwise comparisons. So the event status, right? So there are 6 assumptions when it comes to the Kaplan-Meier test. We're going to go over each of the 6 cursorily. So the first is that the event status should be mutually exclusive, either yes or no. There's no, there's no almost, there's no crossover, right? There's yes and no. So it should be, and also collectively exhaustive, where we know that the event was either censored or the event occurred or did not. Right? So our event fits these criteria. Right? So we just want to know, did people start smoking again, right? So that's yes or no. All right, the survival time. Right? So the time to the event or censorship must be clearly defined and precisely measured. Right? We mentioned our time metric, such as days, weeks, months, years. Right? And ours is 104 weeks, right? So 0 to 104 weeks, right? So clearly defined, precisely measured. So we meet assumption 2. And then where possible, of course, left censoring should be minimized or avoided, right? So that's where we have problems beginning in our observation time and looking at that in relation to our event. However, we know, when the interventions end, and as far as we know, there's no smoking going on at that point, so this left censoring should not be a problem for us. Right? This would be more of a problem perhaps if we say, how often do people quit smoking after they develop a certain disease, like such as a lung disease, but our observation period begins after somebody finds out they're diagnosed, right? That's more of a problem. Right, so there should be independence of censoring and the event, right? So in other words, no informative censoring, right? So the reasons why the cases drop out are not related to experiencing the event, right? So we don't know if this actually happens or not, and that's a problem because it leads to bias, but we're assuming this is not occurring. Right? And of course, there should be no secular trends. So we're going to mention later that you can't actually control for any covariates, right? So we're just looking at the survival curves. So secular trends are those outside influences, right, that could impact experiencing the event, such as if somebody designs a new medicine that, you know, you take a pill and you quit smoking, and one of the groups takes that, then it looks like, you know, that the intervention is more effective when it's really the secular trend or something else introduced in the study that's causing the smoking to be quit or held off longer. Again, that creates bias in the results, of course. And number 6, the last assumption, right? There should be a similar amount and pattern of censoring per group, right? Or that is set also to create bias. Now, we'll show in the analysis how this is easily observed. All right, so we need 4 variables. Count them, 1, 2, 3, 4. 4 variables to perform our survival analysis. We need 1, the case identifier, that's the variable ID. 2, the survival time variable, so the time as it measured. 3, the event status variable. Did the event occur? Yes, no, right, censored. And 4, for us, the intervention groups, right? So we can get our curve for each group. So we can look at the data really fast to see what's happening. All right, so here's our data. We go to data view. We could see it all. We'll make it ascending. We'll say it looks good. So we have our variable ID. So that allows SPSS to sort the cases. The group. So that's the intervention group, the hypnosis group, the control group. The time in weeks, how many weeks until they relapsed into smoking. 60 weeks, 63 weeks. That's the status. That's either censored, right? 0 is censored, and 1 is the event occurred, right? That they started smoking. Now here's what I was saying before. So 1, that means the event occurred. They started smoking again at 63 weeks. All right, that's clear. But here, 0 means they didn't experience the event. They didn't relapse. So why is there a 60 here, right? If they didn't, this is where we either lost track of them, or if it was 104, that would be, you know, where we lost track of them because it was the end of the study. But that means this person did not experience the event, and they exited the study at 60 weeks. That's when they left. And then age and education will be used later on. Okay, so we looked at the data. Right, so now we're going to perform the Kaplan-Meier. So we're going to go into SPSS, analyze survival Kaplan-Meier. We're going to enter our time, enter our group, enter our ID, then define our status. Right, you'll see that. Then the next slide, we're going to go in that options box. You'll see survival and mean and median survival are checked by default. We're going to check survival and then click continue. So let's do that. So there we go. Analyze. Then we go down to survival, Kaplan-Meier. All right, now here we go. We take the participant ID, that goes into label cases by. We put the time, let's stretch that out a little so we can see. Time goes in time. Status, censored or the event, goes in status. Right? And then group, that's where we're getting the curves for, goes into factor. Right? So then we could look around, you look at options, you see survival tables, mean median, and then we want to click survival, continue, compare factor, right? We want to check these 3 and pool over strata. We need 2, so we click continue. Right, so we'll mention that. And then don't forget, under status, we want to click that. Well, keep it in there and click define event. And then 1 means the event occurred. So we click that, continue, then we can paste it and run it. All right, so there. Now we're going to go over one more slide. Just go over the last options box we went over. Then we're going to go over, I don't want to give too much at once where we can't remember it. So we did all this, then we clicked the compare box, remember, we put the log rank Breslow, pooled over strata, and continue and paste. Then we came out with our output. So case processing summary, what does this indicate? So this is indicating there's a similar number and percentage of censored cases per group. Specifically, each of the 3 groups are missing 7, right? There's 7 censored cases, right? And that's 14% of each group. So then we want to look at the overall comparisons to see if there's a statistically significant difference within the 3 curves, a curve for each group. And we see, right, so if we look at the log rank Mantel-Cox, that there is a significant difference between the curves. Right, and we can also look at the mean and medians for the survival time. Okay, so we know there's a significant difference, but who held off on smoking the longest? The experimental group, right, has the highest mean to the event. That means that their average time to event was 67 weeks, 67.74. So almost 68 weeks, right? So the average person in the experimental group after the intervention did not smoke for about 68 weeks. And we see in the control, it's almost half that, right? 38 weeks they started smoking again, the average person. And the hypnosis group is somewhere in the middle, where the average person started smoking 45.38 weeks after the intervention. Now we can actually look, right? So this comes out also in the output. These are the actual curves, and what do they tell us? So the green is the experimental group. So you can see their trajectory is far to the right, and it ends at 100. So what that's indicating is the average person in this group, right, they started smoking when? Way out here. So you see time to event, 20 weeks, 40 weeks, 60 weeks, 80 to 100. So the time to event, right, is what starts way out here. So they didn't start smoking again, these people, till further along in the study, as opposed to the other 2 groups, such as the blue control group, where the smoking started right here, right? So right at about 30 weeks, and then just progressed on through all the way here. And then you see the cumulative survival total up here. Okay, now note, right? Note, the Kaplan-Meier provides an analysis of time to event per group. However, covariates cannot be introduced into the analysis. Right? So how can we perform a survival analysis while considering the impact of covariate variables? Right? So we saw in the data that we actually do have education and age there. So if we wanted to control for the effects of those while we look at, the relapse, how can we do that? For example, what if we know that smoking is linked to age and education level? So we want to control for these variables in the analysis to better observe the intervention effects, right? In other words, when we look at the rate that people start smoking again, we want to make sure it's not due to age and education level, right? So we want to take the effect of those out and then look at the statistical significance and relapse rates. To do that, we could employ the Cox proportional hazards. So this is another, right? So this is the second survival curve that we're examining, right? So the Cox proportional hazard model examines survival time for event for groups, right, such as our 3 study groups, while considering the effect of predictor, also known as explanatory variables. So this procedure is more analogous to regression, other than the non-parametric Kaplan-Meier test, which is a rank test. No, it's a non-parametric rank test. So one of the assumptions of the Cox regression are the covariate variables are at the same level of influence of the event over time, at each time period. Right? So if you suspect that that's not the case, you can also consider the Cox regression with time-varying covariates, which is also available in SPSS. We won't be going over it, but it's good to be aware of it if there's some special reason to think that there's a differential impact over time points. So if we were to do the Cox proportional hazard model in SPSS, it's not unlike the Kaplan-Meier. Okay, so again, we go to analyze survival and then Cox regression now. We put in time just like before. We put in status like before, but you'll see there is not a box for factor like in the Kaplan-Meiers. So we're going to enter the covariates in the covariates box, right? Okay, then next, we're going to bring the we're going to click categorical. There's a categorical box. We're going to specify which variables are categorical and specify the reference group, which is going to be the last group by default. We could change that to the first if we like. Right? Then we're going to click plots. We want the survival. We're going to put the group, right, in the separate lines for. That's to produce the survival curves again. Then under options, we want to make sure to click the 95% confidence interval, CI for exponent B. Right? So that's if we want to report this in a paper, we always include the confidence interval. And then we have our OK or paste. So let's go ahead and do that now. All right, so analyze, survival. Right, and there's the Cox regression. There's the time varying we mentioned, but there's the Cox regression. That's what we're doing. So we expand it here, and we put time and time. We put status and status, and don't forget we define the event, which is one meaning they relapsed, and continue. Then we put the age, which is continuous, education, which is categorical, the covariates, and group. So there we have our covariates. So then there's the categorical box we mentioned. We click on that, and it's asking us, hey, which of these are categorical covariates? Right, so education and group. Right? So age is not, we leave it there. Then you'll see here the reference category, also known as the reference group, is by default the last category. So for education, we have 1, 2, 3, 3 being graduate school, that will be the default. And group, we have 1, 2, 3, 3 being the experimental group and the happiness intervention, that's going to be the reference group. So we know what the reference groups are. We click continue. We look at plots, right? So we might want to say survival and then put group in the separate lines for. So that's just going to give us that extra survival plot that we got before in the Kaplan-Meier. Continue. Then options, we want here the 95% confidence interval for reporting. And then we're all set. And then we paste it. Well, it used to go to that automatically. And then run it. And there we go. So let's look at the pieces we have here. So there we go. Now, the first box we get is a case processing summary. So this is similar to the Kaplan-Meier, where it's telling you, the number of people that were censored, number of percentage censored, the number and percentage that experienced the event. But notice it doesn't break down censoring by group, right? So we can't see here that the censoring is equal among the three groups, right? The 7 people censored per group, right? 14% per group. So that's seen in the Kaplan-Meier, but not here. So we could always run it the other way too to get that other box. Right, then we get the omnibus test of model coefficients. So that's going to tell us the statistical significance of the entire model. And what does it say? The overall model is statistically significant. So that's great news. So there is some significant difference, right, between the survival curves and the predictors and the variables explaining the event, right? And then we have, just like a regression model, the variables in the equation. This looks a lot like the binary logistic regression model. So what does it tell us? So first, we see the statistical significance of the individual predictors. So all 3 predictors have statistically significant findings. So we should look at each of them. All right, so the next thing we want to look at are the hazard ratios. So what are these? So the hazard ratio is the ratio of the hazard rates by the levels of the predictor variable as per units of time, right? So what are the difference in the ratios of experiencing the event, right, for the levels of the predictor variable, such as, study group, among the study groups over each week of time. So for example, we'll use a couple of examples here, but for example, if we had an experimental controlled drug treatment study with the survival curve and we had a hazard ratio of 2, that might indicate the control group die at a rate 2 times the experimental group in the unit of observed time. So if that's in a year, they're twice as likely over the course of the year to experience the event, which is unfortunately mortality. Okay, so if we start looking, right, at the hazard ratios, right, the first thing we want to keep in mind is to the left in the variables in the equation box, we have group. Now all it says is group and then group with a 1 and a 2 next to it. So we don't want to get confused. So what does that mean? So the first group without a number, that's the reference group. So that was the final group in the categories. So that's the experimental group. And groups 1 and 2, 1 is the control group and 2 is the hypnosis group, right? So we know that 1 and 2, the findings of 1 and 2 are both being compared to the reference group, which is the experimental group. And what's it saying? So first, group 1, we see a hazard ratio of 4.76. So what that's telling us is over the time period, the control group is almost 5 times, right, 4.76, almost 5 times more likely to experiencing the event of smoking relapse in reference to the experimental group, right? And then also keep in mind, it's not shown here because we kind of sectioned off the box, but while controlling for age and education level. And then next, we see it's also significant for group 2, right? I mean, the hazard ratio is a little lower, so what's it saying? That the hypnosis group is over 4 times, so HR 4.09, 4 times more likely to experiencing the event of smoking relapse in reference to the experimental group, which is the reference group, while controlling for the effects of age and education level. That's very informative. Then what else? Now keep in mind, age is a continuous variable. So don't interpret the hazard ratio in the same manner as the categorical variables. It's a little different, so we can't call it like that, but we can do it with education level, right? So education level 1, right, which is high school GED, are over 2 times more likely, 2.24, more likely to experience the event of smoking relapse in relation to the reference group education level. That's not L as in Spanish. Education level of graduate school, right? And you'll also say that the education level 2 is not statistically significant, right? The p-value is 0.667. So there we go. There are findings. Now, the Cox proportional hazard automatically by default is giving us this, the survival function for the covariates. But remember, we put in for our proportional hazard to look at this again, which are the curves for the 3 separate study groups. Okay, so there we have it. The special consideration in longitudinal analysis of whether and when, right? And the use of survival curve analysis, Kaplan-Meier and Cox regression to study event occurrence over time for different groups. All right, now next week we'll be looking up the write-up and report for these studies. Okay, thank you for watching, and we will speak then.